All right, let's take a look at the re-exam of July 2022. It was assignment number 3 that I was asked to go over, so let's just have a look. Assignment 3, Arrhenius equation. We're given some data, blah, blah, blah. Now, I've looked at it already a bit, and I think one of the issues you might have with it is that you're not being given initial estimates for the coefficients you have to find down here. I can see in the solution there actually are some, so I'll be using those. Otherwise, you're going to get a different result. But I'm being told this is the equation we're using. I have a constant r of this value, and then I got a bunch of data that I can try and work with. And the first one we're being asked for is perform a nonlinear regression on the data using the model here. So basically one constant times the exponent of another or minus another constant times x, and estimate the values of b0 or beta 0, beta 1, a and ea. So I've already totally cheated and copied the data into Excel. So we have it here. Let's just zoom in a bit so you can easily see what's going on. And I've taken the two initial guesses that are not in the assignment. I think they might, maybe they should have been. I don't know. I didn't write this exam question. But I'm gonna take these and use them. So these are my starting guesses. And I also have my constant for the R down here. And if we just jump back to this one, I'm just gonna steal the equation so it's easier for us to see what we're doing. And this is basically the one that I'll be working on first. I want to optimize this equation. So I'm going to do an estimated, or what my equation tells me. I'm going to type in the equation I have down here. So this one is going to be equal to beta 0. I'm going to select the one below. I'll explain in a second. I'm going to lock that in, times the exponential of minus beta 1, lock that in, times my x value, which is 1 over t in this case, and finish off the parentheses and drag all of these down. So what you'll see me doing quite often is I'll take the initial guesses, copy them down here. That way I can easily reset if I have to. I don't have to go and find them from somewhere else. So these are my I can't spell, estimated constants. And these are my estimated values. And then of course I need my difference between my actual value, my estimated value, and I want to square those. And I just want to fill that down. And we're just going to move this over here. And then I'm going to say, okay, I would like to sum up all of these. And that's going to be my SSE, or sum of squared error. So this is the one I want to minimize by changing the two constants that I have here. So we're just going to go to data and solver. We're going to say that's the one I want to minimize, E12 in my case. And I want to do it by changing these two constants. And then I'm basically going to ask Excel to solve it. Excel says it's very happy and found a solution. So these are the two coefficients that I have. So that's actually half of the initial assignment here, because I've estimated the values of beta 0 and beta 1, but I'm actually being asked to estimate also the value of A and the value of EA. And for that, I'm going to need this equation, so I'm just going to copy that, take that over here so I can see what I'm doing. So now I need to calculate my A and my EA. Now, for the A part, if you look at the equation, that's very simple because the A is multiplied by the exponent. So my A and my beta 0 are basically the same. So all I have to do is to say, there we go, my A is the same as beta 0. For the EA, I have to calculate it because that's part of this expression here. So in this case, I need to take the value of my beta 1, that's the one I have there, And if I recall right, I would have to multiply by R to just get the EA value. There we go. And does that check out? I'll just check my solutions over here. That all looks fine. So now I have my A and EA, and that was the first part of the question. Figure out beta 0 and 1, and figure out what A and EA is. Then we're being asked to determine the coefficient. Again, I'll not ask you to do that, but we can easily do it. So in order to do that, I need to calculate my sum squared total. I can just do that with the davsq command, and I'm gonna select all of my y values. There we go. And then if I want to calculate my r squared, it's just gonna be 1 minus the ratio of SSE over SST. And I'll just change this so we can see the value. Format cell, number, general, there we go. So I get an r squared of 0.999 in this case. So that was the second part of this, figure out the r squared value. Then we're being told you can actually rewrite it. You can take the logarithm on both sides. And we're now asked, can you please perform a linear regression using this new model? And yeah, sure, we can do that. So in order to do that, I'm gonna move over to the right a bit and say, well, my 1/t values actually don't change. They're gonna be the same. So if you look at the equation, where is it? Here it is. We'll just snatch that so we can see what we're doing. I still want my, what's it called? 1/t. That's still what I want here. That's still my, how do you say, my x value. My y value is gonna be the natural logarithm of kr. So I'm gonna use ln of kr and say, okay, please take the natural logarithm of my kr value over on the left, fill that down, and then I'm basically gonna ask Excel to do a standard linear regression on these two values. So we're gonna go to data analysis, find our regression, and oh dear, I've already been using it. We'll have to check. So I'm gonna say my y range. Well, my y range is this one. My x range is 1/t. I have labels, or I've selected with the labels for both of them. And I want, just give me all of the plots. Where do I want to output my information? Let's just output it there. And I'm gonna say okay to that. I get my linear regression. And is that all we were asked to do? Perform a linear regression. We've done that now using this. We now have the values of beta 2 and 3. That's basically the two coefficients down here. I just need to make sure which is which. So beta 2 is my intercept. So this is beta 2, beta 3. And then we're being asked if we can then estimate the values of A and EA for this one. And I'm just going to use the equation over here and say, well, if I have my intercept, that's basically the one I have here and here. So my A, well, this is the logarithm of A. If I want to find A, well, I can just take the exponential value of that one. That should give me my A value. Very high number. Does that check out? That looks fine. And the other one I was asked to find is my EA value. So in this case, I will then say EA. And I basically have to take the value that I have here, and I, just like before, have to multiply it by my R value, which I had over here somewhere. There we go. And oh, I have to change the sign because it's minus. But that's fine. We'll just plop in a minus. There we go. So now I've estimated the values of my what's it called? A and EA, and that's basically what I was asked to do. Compare the values. Yeah, we can do that. Let's just see, we had our A and EA over here. Let's just copy them down here. That didn't work out. Hang on. Let's just paste them only as values. And we can see we have quite a big difference in our A estimates, but our EA estimates are not too far apart. That's not that uncommon when you're using these methods where you turn it into a natural logarithm. It's not uncommon that you will get quite different estimates of the one you take the logarithm of. But we've done what we've been asked to. We found the values, we've compared them. Then we are asked to comment on the validity of the linear model. Okay, we need to check for homoscedasticity, whatever that's called. You know, I can't pronounce that, but I can show you how to do it. And it's very easy because I asked Excel, so we'll just data analysis regression. I asked Excel to give me all of the plots, just give me all of them. And then all I have to do is find the right one, which is hiding where, there it is. My residual plots looks pretty random to me, I can't see any trends. So that's the first part of it. Check for this, and I say, yeah, I don't see any trends, that's perfectly fine. Are the residuals normally distributed? Well, we just go to our normal probability plot, and that looks pretty linear to me. So again, check. That conforms to normality as well. And then we have the final one. Boy, this is a long one. Use the linear model to estimate a 95% confidence interval for KR when T is 298. Okay. Actually, that must be for the linear one, yes. I'm just gonna delete this so I don't confuse myself. There we go. So in order to do this, I have to start out, let's call it E, just so we know what we're doing. First up, I have the value that I've been asked to calculate for, 298. And then if I want to make it easy for myself, I'm just going to say this is 1 over T, because that's what we've been using. 1 over that one. And then I basically have to find my SXX. So that's basically my def squared of my X values, which are all of these lovely things. There we go. And then I need my X bar. So that's my average of my X values. There we go. I need my variance. I need my SE. So I'm gonna start by calculating my variance. We have it there. And of course we need the equation for that if you don't remember it. So actually the one I have in my notes are the one for the standard error, or standard deviation, but we'll just use the part before we take the square root and say, okay, sure. So I need my residuals. That's the one I have there, times 1 over the number of observations. That's the one I have there, plus, and then I need my x0, which is this one, minus x bar, which is that one, and I need to square it. And then I need to divide it by my SXX. That's the one I have there. Let's hope I did that right. There we go. And if I want this one, well, I'm just gonna ask for the square root of my variance. Then I have this one. I need my y hat. So in order to find my y hat, well, all I have to do is I have to predict what do I think this is. So in this case, I have my intercept plus my new x value times the coefficient of that one. So that's my new predicted value. I expect y hat to be minus 9.8. And finally, I can then start to figure out my t-test value. So I need my t for the 97.5% confidence interval. And all I need to do for that is I need to use my t inverted. So we just say t inverted of two-tailed 0.05, and then I need my degrees of freedom, which I can never find. They're up here somewhere. Bum, bum, bum. That must be my degrees of freedom, if I remember right. No, did I do it wrong? Oh yeah, sorry. Where is it? Bum, 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 bum. There we go. Degrees of freedom, 2.306, yes. And then I can basically just take my upper, lower, and all I need to do for this one is that I take my predicted minus t times SE, and my upper is gonna be my predicted plus t times SE. There we go. Does that check out? Basically does, so this is my... Actually, if I subtract that, that must be my lower, right? So I messed it up. I'll just change it here. Lower, upper. Then it's fine. Now keep in mind, this is for the logarithm of these. So I need my upper and lower again, and I basically need to take the exponential of what I have here in order to get the actual upper and lower limits for this. And that basically gives me my 95% confidence interval for KR when t is 298. So my confidence interval in this case is from, where's my lower? That's my lower, from 5.34 to 5.36 times 10 to the minus 5. So that's basically how you would solve all of this. It's quite a big exercise, all of this, combining both nonlinear and linear, but that's the walkthrough of it.